Hey everyone, so today we're going to be doing the 2022 AIME II Problem 6. I know it's been a while since my last video, but trust me, I haven't forgotten about this channel. I've just been really busy with schoolwork, among other things, but hopefully that's going to settle down. Yeah, let's just jump straight into the problem. The problem says let x sub 1 less than or equal to x sub 2 less than or equal to ... x sub 100 be real numbers such that the absolute value of x sub 1 plus the absolute value of x sub 2 all the way to x sub 100 is equal to 1, and the sum of each of these terms is 0. Among all such 100 tuples of numbers, the greatest value that x sub 76 minus x sub 16 can achieve is m over n, where m and n are relatively prime positive integers. Find m plus n. So first, let's just try to make sense of this problem. We're given a sequence of 100 terms. They all sum to 0, but when we take the absolute value of each term, they sum to 1. And this implies that some of these terms are negative, because when you take the absolute value of a negative number, you'll get a positive number, and that will increase the sum. And we are asked to maximize the difference x76 minus x16. So let's just try to maybe make some deductions from this information. So we have that these terms are in increasing order. And we know that if we take the absolute value of each of the terms and then add them up, we get one more than if we were to just add them all together. So what does this tell us about the sum of all the negative terms in the sequence? Well, that means that the sum of the negative terms must be negative 1/2. I'll just write that down right here. And the reason this is the case is because we know that the total sum will be the sum of the negative terms plus sum of positive terms. And this is equal to 0. If we take the absolute value of all of these negative terms, well, first, if we take the absolute value of all the positive terms, that does not change anything. So this is the same. If we take the absolute value of the sum of the negative terms, and then add that, this becomes 1. So this means that if the original sum of the negative terms was negative 1/2, and we take the absolute value of that, we get 1/2. And this is 1 greater, which is exactly what we need because we know that this doesn't change. But if this increases by 1, then this satisfies this other equation right here. I hope that makes sense. And so if we know that the sum of the negative terms is negative 1/2, what does that tell us about the sum of the positive terms? That means that the sum of the positive terms is 1/2, or positive 1/2. So I'm just going to write the arrow here as this is equal to 1/2 because these are the sum of these two quantities is going to give us all the terms in the sequence, and that's equal to 0 according to the problem. Okay, now how can we maximize x sub 76 minus x sub 16? Well, we want x sub 76 to be the greatest, as big as possible, basically. And we want, so let me just write that down, as big as possible. And we want x sub 16 to be as small as possible, because, for example, let's say it was negative, then we're basically just adding sort of the absolute value of x sub 16. So I'll just write that here as well, x sub 16 as small as possible. Now, we know that the sum of the negative terms is negative 1/2. And we know that these terms are ordered in increasing order. So this means that x sub 1 is less than x sub 2, or less than or equal to x sub 2, which is less than or equal to x sub 16. So if we want x sub 16 to be as small as possible, then we want all of these terms to be equal. Because we know that x sub 16 has to be greater than or equal to x sub 1. So the smallest x sub 16 can be is if they're equal. So x sub 1 equals x sub 16. So if these two are equal, and all of the middle terms are bounded by x sub 1 and x sub 16, that means that all of these middle terms must also be equal to x sub 1, which is equal to x sub 16, which means all of these terms are equal. And we have 16 of them, so let's just call each of them, let's say they're equal to a. We have 16 times a is equal to negative 1/2, which means a is equal to negative 1 over 32. And this is going to be our value of x sub 16. Now, similarly, we want x sub 76 to be as big as possible. Well, first, notice that we're going to want all of the terms from x sub 17 to x sub 75 to be equal to 0. Because if we want x sub 76 to be as big as possible, we basically don't want any of these other terms to take away from this positive sum, which we know is 1/2. And from a similar logic as what we did here, we can show that x sub 76 must be equal to x sub 77, which is equal to x sub 78, all the way to x sub 100. Because we can basically say that x sub 76 is less than or equal to x sub 100. And that means that the biggest x sub 76 can be is if it's equal to x sub 100, which means all of the middle terms must also be equal to those quantities. Okay, now how many terms do we have here? We have 100 minus 76 plus 1, so that's 25. So we have, let's say, 25b is equal to the sum of all of them, which is 1/2. And notice that we can just say it's the sum of all of them because we set all of the other ones equal to 0. If all of the other ones are something greater than 0, that would take away from this 1/2, which would make b smaller. So from this we get b is equal to 1 over 50, just dividing 25 from both sides. And so our answer, which is the difference of these two quantities, will be 1 over 50 plus 1 over 32. And you can do the math if you want. This is equal to 41 over 800. These are relatively prime, so our answer is going to be 41 plus 800, which is 841.